Hello, future engineers. So, last time we already tackled the introduction for the application of the definite integral in determination of the volume of revolutions, or the solids of revolution, or the areas, or sorry, the volumes of region between curves. Let's have our first example. Aron mas masabtan na to siya. So here we have a volume of the solid formed by what? We have a solid formed by revolving the region bounded by the graph f of x is equal to sine x, square root of sine x, and the x-axis, where our x is greater than or equal to 0, but less than or equal to pi about the x-axis. Now, first, if we don't have a graph with this one, has a similar concept with the getting the area, diba? We first is if there is no graph, then you try to draw the graph to draw the curve. So since here we already have the drawing of the curve, it is represented by this curve. This is f of x is equal to square root of sine x. Now, on pa other given. Next is we try to see on what axis does this specific curve is revolving upon. So here, uh, the solid form by revolving the region bounded by the graph and the x-axis about the x-axis. So there's no graph there. You'll know that the region bounded by the graph revolves along the x-axis. If you can see here the about the x-axis, it means that the area that needs to be revolved should be revolved along the x-axis. Now this one, that is from 0. So from 0 to, we have here our pi. So this will be the resulting solid of revolution. So first ninyo ibuhat is that you graph. If walay graph given. Next, determine uh, on what axis, or determine the axis of revolution. After determining the axis of revolution, say next na to pangitawon, you try to determine the limits. So our limit here, that is a is equal to 0 and b is equal to pi. By the way, determine the if what you're going what strip are you gonna use. Is it the horizontal or the vertical? No, for this one is already horizontal. Now if you revolve this one, then we'll arrive with this solid of revolution. So that is just simple, no? Applying the concept that the volume for the disk is just equal to pi r squared omega. Then for the times the thickness, that is just equal to pi times the integral of r of x dx from a to b, or simply pi times the integral of our r of x is the function represented by this curve, which is this one, square root of sine x, we forgot the squared dx from 0 to pi. So dali lang din, kaya we will have pi integral of sine x from 0 to pi dx, or we have the pi times negative cosine x. So we evaluated from 0 to pi. So we will have pi, as we'll have negative cosine pi minus cosine 0. Again, don't forget that we'll need to use this one as the in region, or we need to solve this one in regions mode. This is a negative minus negative cosine, so that is pi times, we have a 1 minus negative 1, or the volume is just simply 2 pi cubic units. So yan na lang siya. That's how we're going how we're gonna solve this one. Solve it off revolution. First, you graph. If there's no graph, determine the axis of revolution, and then determine the strip that we're going to use. Is it horizontal or vertical? Determine the limits. And then we have here the formula for a volume. The radius that we are gonna use is the from the axis of revolution, paingon sa curve, represented here by r of x. Now, r of x, actually this is our y, di ba? Mura na siya pi y squared dx. And then we know that y is just equal to square root of sine of x. So our y is governed by this specific function. That's why we have here our radius is the sine of x. And then you're able to get sine of x. And then we have the integral sine of x, which is equals to negative cosine x. And then we evaluated that from 0 to pi, and then we eventually arrived at our solution that the volume of the solid of revolution is 2 pi cubic units. Let's proceed with our second example. This is quite similar with the first example, but if you notice, the axis of revolution, so we have here our x-axis, and then we have here our y-axis. But let's read the problem first. Find the volume of the solid form by revolving the region bounded by f of x is equal to 2 minus x squared and g of x is equal to 1 about the line y is equal to 1 as shown. So sa may given niya diri, we have a curve, we have two curves. This f of x is equal to 2 minus x squared, so that is the curve 1 here. And we have the g of x is equal to 1, this one. Now, ingon niya, asan nito how we're gonna determine the axis of revolution if naatay makita nga about the. So here, the axis of revolution is about the line y is equals to 1. So our axis of revolution is not the x-axis, not the y-axis, but this line here. So saan na to? So we have a this here, no, that is formed here. So sa may bato na to, di ba the volume is just equal to pi times the radius r of x dx from a to b. So what is our radius here? The radius is from the axis of revolution to the curve, di ba, or to the topmost. That is our r of x. Now, from the x-axis, paingon ani nga curve. Let's just delete this para limpyo. So from the x-axis, paingon ani along this one, that is our f of x. Now here, that is our g of x. So saan man nito siya pagkuha? That is just equal to, the r of x is just equal to the f of x minus g of x. Or simply, 2 minus x squared minus 1. Or 1 minus x squared. So this is our radius. That will happen if the axis of revolution is not the x nor the y-axis. So you have the v is equal to pi times the integral of r of x is r of x squared. So that is just equal to 1 minus x squared squared from what is our lower and upper limits? Our lower and upper limits is already shown here, negative 1 and positive 1. Negative 1 to positive 1 dx. You'll have pi as the integral of, we just distribute this one, you will get 1 minus 2x squared plus x to the fourth dx from negative 1 to 1. Our volume is equal to pi times what? X minus 2/3 x cubed plus 1/5 x to the fifth. And to be evaluated from -1 to 1. And if we evaluate that one, we will arrive that our volume is just equal to 16/15 pi cubic units. Okay, let's proceed with our third example. Find the volume of the solid form by revolving the region bounded by the graphs y is equal to square root of x and y is equal to x squared about the x-axis as shown. Okay, so we already have our graph. We have our solid of revolution shown here. So our lower and upper. So for this one, we need, this is a washer. Then we need to use a vertical strip. Again, the volume of the washer is just equal to pi times the integral of outer radius minus inner radius. Okay, don't forget to square that one. Square of the outer radius minus square of the inner radius times the thickness from A to B. Our A or our lower limit is at 0, as we can see here in the graph. The points were given. And the upper limit is 1. So we just substitute that. We have the pi is equal to, what is our outer radius? So this is our axis of revolution along the x. Our outer radius is the function represented by this outer curve. The equation of this outer curve is just equal to y equals square root of x. So that is just square root of x squared minus the inner radius. Our inner radius is the curve represented by the function represented by this curve. That is just equal to x squared. So x squared squared dx from 0 to 1. We will have pi integral of, we will have an x minus x to the fourth dx from 0 to 1. Dali ra kayo, mata-matahon lang. That will become pi times 1/2 x squared minus 1/5 x to the fifth from, the evaluate from 0 to 1. And if you evaluate that from 0 to 1, we can find that the volume formed by revolving this curve, or the region bounded by these two curves, is just equal to 3 pi over 10 cubic units. Now, how about with this one, with the fourth example? We have the find the volume of the solid form by revolving the region bounded by the graphs. Okay, so we have a graph. Y is equal to x squared plus 1, y is equal to 0, x is equal to 0, and x is equal to 1. This is equal to 1 about the y-axis. Now, for this one, our axis of revolution is along the y-axis. So, nituyok siya along the y-axis. And we have a solid form here. We have a solid of revolution form here. It's already shown here. Now, if you can see now, we have a curve here, but we need to get the volume from 0 to here. And so, na nato. So, actually, we can apply the washer method here. For the first one, so mura ni siyang matunga. Here we have the, we'll use the washer method. And for this one, we'll be using just the this method. Okay, let's try for the volume of the washer first. That is just equal to pi times the integral of the y outer, the outer radius minus, this one is the x outer minus the x inner. X because that is the radius is along the X. Squared the X from A to B. What is our lower limit for the washer? The lower limit for the washer is 1. The upper limit is 2. So this is the limit for this specific area na nagamit ang washer. So that is just equal to pi times the integral of x outer. What is our x outer? Our x outer is just equal to 1. So we'll have our 1 squared minus what is our x inner? Oh, sorry, this is dy rather, no? That is in dy because the strip here is moving along the y-axis man. So we have so we need to get, or we need to isolate the y here on the other side. So we will have y is equal to x squared plus 1. We just rewrite that we have y minus 1 is equal to x squared. To get the x, that is just equal to, x is just equal to square root of y minus 1. We just put that here. That is just, we'll have y minus 1 and then squared. dy from 1 to 2. We have pi is equal to integral of 1 minus y plus 1 dy from 1 to 2. Or pi times integral of, we'll have 2 minus y dy from 1 to 2. And then that is equal to pi times 2y minus 1 half y squared to be elevated from 1 to 2. That is equal to pi times 2 times 2, we have 4 minus, we have 2 squared, 4 divided by 2, so 2. We will have 4 minus 2, and then minus 2 minus 1 half. So the volume of the washer, here we'll arrive at our answer as pi over 2 cubic units. Now this is not yet the final answer because we need to find the volume of this using the disk method. Now by this method, that is just equal to pi integral of r of y squared dy from 0 to 1. Okay, from 0 to 1, that is just equal to pi times the radius is constant, that is just equal to 1 dy from 0 to 1 is equal to pi times y to be evaluated from 0 to 1 or just equal to pi. So the total volume of that one is just equal to the volume we got by using the washer method plus the volume we got by using the disk method. That is just equal to 3 halves pi cubic units. Actually, for this one here, no, this is actually just this is just an ordinary cylinder, no? That is just equal to the volume there is just equal to pi r squared h, or pi times the radius. We have 1 squared. Then our h is just also 1. Then we will have our pi.